In this class, we will discuss about numerical integration techniques. For example, let us say we have an integral function like this. Integral f of x dx between the limits a to b. I is equal to integral a to b f of x dx. So this is the function. This function can be anything, algebraic or trigonometric or exponential, logarithmic, whatever it is. So it has to be found out between the limits a and b. So a is the lower limit, b is the upper limit. So that interval we are going to write like this. So this is the interval. This is called as interval. And what happens? This interval is divided into number of divisions. B minus a divided by n, where n is the number of divisions. This is denoted as h. So n is the number of divisions. For example, I give an example here. Suppose if you take a is equal to 1, b is equal to 2, and n is equal to 5. Then h will be b minus a, that is 2 minus 1 divided by 5, which is 1 by 5, which is 0.2. That means the intervals are 1, 1.2, 1.4, 1.6, 1.8. These are the intervals. So h value is 0.2 here. Suppose if you take n is equal to 10, then h value will be 0.1. So the intervals will be 1, 1.1, 1.2, 1.3 up to 2, like that. So actually the physical meaning of this is, suppose if you have a curve y is equal to f of x curve, this is x axis, y axis. Now let me take a curve something like this. This is a curve y is equal to f of x. So if you take two values of x here, this is the origin. I will draw two coordinates here. This is a, this is b. Now if you find the area under this curve between the values a and b, so that is nothing but your integral a to b f of x. This is what you have done in your PUC class. Area under the curve gives the integral. Of course, between two values of x, this gives the I value. So that is the physical meaning of that. Now here, this interval is divided into so many subintervals like this. For example, here I have divided this into 5 subdivisions. So n is equal to 5 here. That is it. So that n is called as number of subdivisions. You can take it as subdivision. So between a and b, it is divided into number of subdivisions n. Based on the value of n, h is calculated using this form, b minus a by n. Now here, this area under this integral can be found out using some numerical techniques, because integration sometimes it will be difficult if the function is complicated. Differentiation you can do by using chain rule, product rule and quotient rule, whereas integration it is not so easy. So either you have to go for integration by parts or integration by substitution or some other standard formula may be used. But if the function is complicated, where you cannot find the integral value exactly, then you have to go for approximate value. Approximate value of I can be obtained by using some integration techniques. So there are 4 methods of numerical integration we have to study here in this course. The first one is trapezoidal rule. Second one is Simpson's 1/3 rule. Third one is Simpson's 3/8 rule. And fourth one is Weddell's rule. Of course, there are some more methods are also available, but for your course, these 4 methods we are going to study. So each method has got one formula, standard formula, which you have to remember. Using that formula, you can directly substitute the values and get the integral value, I value. Now in that, let me take the first one, trapezoidal. So I give just the formula, let us not worry about the derivation, we will take numericals. Trapezoidal, first one is trapezoidal rule. The standard formula or the equation for trapezoidal rule is I is equal to integral a to b f of x dx, f of x dx is equal to, so this is what we have to evaluate, f of x can be any function of x. This is given by h by 2 into y naught plus yn, y naught plus yn plus 2 times y1 plus y2, 2 times y1 plus y2 plus y3 etc. up to yn minus 1. So this is the formula. Here, as I already told, h is this interval length, or this is called as width. That is the interval width. So in this example, h is 0.2, like that we have to take. So a and b he will give, f of x he will give. So this is the formula used to find the integral. Here you should know that what is y naught. So y naught, if you divide this like this, so this first ordinate is there, this is your y naught. Last ordinate is yn. First value of y at a at x is equal to a is y naught. Last value, that is at x is equal to b, whatever value of y is there, that is yn. So here you can see that y naught plus yn we have to take first. Then plus 2 times the other coordinates, other ordinates. Other ordinates means, for example, if this is y naught, this becomes y1, this becomes y2, this becomes y3 like that. Okay? So this is the formula till the last part 1. Last part 1 is yn minus 1. So till then we have to take the values and we have to just substitute in this formula. So we need to find these values first. These values, the values of y. So here f of x is nothing but your y. So we have to give the values of x, get the values of y at these values of x, and they will give these y values. Substitute those y values in the formula and simplify, you will get the I value. So the one condition here is, if at all you want to apply here, the number of intervals may be either odd or even. The number of intervals may be odd or even. So whether you are going to divide that interval into odd number or even number, that is n may be, the meaning of this is n is odd or even. Whether it is odd number 5, 10 like that, so you can use this formula. So trapezoidal formula can be used for any value of n. It can be odd or it can be even. Second one is Simpson's 1/3 rule. Simpson's 1/3 rule. So you have to remember this formula. Once you know the formula, rest of the procedure is very easy. So Simpson's 1/3 rule, I will give the formula. It is similar to that. So I is equal to, see, it comes like this, h by 3. I is equal to integral a to b f of x dx. The f of x is equal to your y is equal to, here the formula runs like this, h by 3 into, see, I have given the equation, h by 3 into y naught plus yn. So the first two terms are same as that of trapezoidal formula, plus 4 times 4 into sum of odd ordinates. Odd ordinates. What do you mean by odd ordinates? y1, y3, y5, they are called as odd ordinates. So sum of all odd ordinates means y1 plus y3 plus y5 like this. That is sum of odd ordinates plus 2 by 3 2 times sum of even ordinals. 2 into sum of even ordinals. What are the even ordinates? Even ordinates will be this y2 plus y4 plus y6. So there is a change here. First two terms are same. 4 times sum of odd ordinates plus 2 times sum of even ordinates. So if at all you want to use this Simpson's 1/3 rule, n should be even. Number of intervals should be even. That is it. Okay. This is the condition. So here it can be odd or even, whereas here n should be even. Using the Simpson's 1/3 rule. Next we will go to Simpson's 3/8 rule. Simpson's 3/8 third rule. So I am giving the formula for all. Later I will take a problem. Simpson's 3/8 rule. So Simpson's 3/8 rule, it states like this: I is equal to 3h by 8. So that is a to b, integral a to b f of x dx. This is something what your y is equal to 3h by 8. So that is why it is 3h rule. This is 1/3, 1 by 3. This is 1 by 2. This is 1 by 3. This is 3 by 8. Like that you have to remember. Into y0 plus yn. So the first two terms remain same. Plus 3 times. So here little bit different is that it is not odd ordinates. It is like this: y1 plus y2 plus y4 plus y5 up to yn minus 1 plus 2 times y3 plus y6. So whatever is not there here, that we have to do y3 plus y6 up to yn minus 2. Yes, this is Simpson's 3/8. Here also the number of divisions or subintervals should be multiples of 3. So n should be a multiple of 3. What do you mean by multiple of 3? Multiple of 3 means it will be 3, 6, 9, 12, 9. Okay? It can be odd or even, but it should be multiple of 3. So then we can go for Simpson's 3/8 rule. Then the fourth one is the Weddell's rule. So each method will have its own merits and demerits. So Weddell's rule I will write now. Fourth one. Weddell's rule. So you have to remember the equation: I is equal to integral a to b f of x dx, where this f of x is your y, is equal to, now I will give the Weddell's rule. The Weddell's rule states that it is like this: 3h by 10. 3h by 10. So coefficients is varying. Here it is 3h by 8, it is 3h by 10 or 3 by 10 into y0 plus y1 plus, so first two terms are same, plus y2 plus y4 plus y8 plus y10 etc. up to yn minus 4 plus yn minus 2 up to this. Then plus it continues 5 times. Here there is that means 1 is there, 1 into this. Next to plus 5 times y1 plus y5 plus y7 plus y11 up to yn minus 5 plus n minus 5 plus yn minus 1. So this is the second term plus 6 times y3 plus y9 plus y15 up to yn minus 3 plus 2 times y6 plus y1 plus etc. up to yn minus 6. Of course, here, there are so many terms, 11, 15 and all is there, but normally that much terms will not be there. So if it is restricted to only 8 terms, so here the condition to apply this Reynolds rule is at least 7 intervals should be there, minimum 7. So n is should be greater than or equal to 7. So minimum number of sub-intervals should be 7. It can be 8, it can be 9. So n should be greater than or equal to 7. So these are the conditions that should be satisfied for the values of n. For applying trapezoidal rule, n can be either odd or even. For applying Simpson's 1/3 rule, n should be even. For applying Simpson's 3/8 rule, it should be multiple of 3. For applying Reynolds rule, minimum number of n should be 7. So it should be more than 7. So these are the conditions and these are the formula. So once you know these formula, better you remember the formula. And of course these three are, you can easily remember. This Reynolds formula only little bit more up. I think you may get only up to this. See, suppose if there are 7 terms in Reynolds rule, if there are, let us say 7, n is equal to 7. N is equal to 7 means this term will be there, this term. Here n is equal to 7. This term will be there, this term. This will not be there. y8 will not be there. Then coming to here, this will be there, this will be there. y7 will be there. This will not be there. Correct? Then when you come to here, this will be there, this is not there. So when you come to here, this will be there, this is not there. So maximum 7 they may be. But this is general formula. If it is more than 7, then this formula we have to use. As the number of intervals, sub-intervals increase, accuracy also increases. So that is very important. As in any method, as n increases, accuracy value of I also increases. So as n increases, h decreases, correct? H decreases because h is equal to b minus a by n. As n increases, h reduces. So as you keep the width of the interval lesser, you get more accurate result. So anyway, why this numerical integration is important is for some complicated functions it is difficult to integrate. Then we go for this numerical integration technique. So classical method cannot be used. Integration by parts or integration by substitution method cannot be used. Then we go for this numerical integration. So there are 4 formulas. So now next class I am going to take up problems on this and we will do the problem.